Okay, guys, today we are looking at lesson 18, and our objective in lesson 18 is to identify and combine like terms within an algebraic expression. Okay, so we're going to be using the distributive property, and we're going to be combining like terms. None of this is new. This is, and that's good. It's a good thing that you did. And this is what the quiz is on Wednesday. So we're going a little above what the textbook asks us to do in this lesson. The textbook in this lesson just asks us to identify and combine like terms. That's a little elementary for where you guys are as an honors class. So we're going to be kind of using distributive property and multiplying and combining like terms. Okay, so simplifying expressions involving distributive property and this. So we need to get some definitions, right? What is the definition of a like terms? Yes.
Like, wow. Wow. It's like terms are the same. Like they have the same qualities.
They have the same qualities?
It's not, I don't know, it's like...
Why'd you say wow?
What's...
coefficients with the same
I
variable.
know it, I can write it down on a piece of paper, but I can't say it.
Okay. Combining like terms. Anybody got a little better definition than wow? Wow, it's like terms that have the same
Combining
quality.
them or what like terms are?
Aspen, what you got?
Coefficients with the same variable, I guess. Why are they?
Brooklyn?
Wait, do you want me to say combining like terms or
No, what are like terms?
Okay, they're terms that have the same variables in the same order.
No.
Exponents. That's a good one.
So they're terms that have the same variables, and the variables have to have the same exponents, right? So there's two conditions. It's two or more terms that have the same variable, and the variables have to be raised to the same exponent. I just really prefer the word exponent here to power. Exponent. This is lesson 18. Those are like terms. Yeah, this is a vocabulary word for Unit 2. Very much. All right, yes. All right, so let me show you why it's important that we have this definition the way it is. So we could have this. Now, these two terms have the same variables, right? And they have the same exponents.
But they're not raised, they're not in power.
Right, the variables aren't raised to the same exponent. Okay, so the corresponding variables have to have the same exponents. So if I have an x cubed in one, I have to have an x cubed in the other, a y squared and a y squared. The same variables have to have the same exponents. Yes, Elijah?
So normally you would add the exponents together, but here you add the bases together, if they're like terms.
Not bases, you're adding the
Exponents. No,
Constant.
coefficients.
Constants are the ones that don't have exponents. So it would be
Yeah.
7x to the 5th, y to the 5th?
No, you can't add these because they're not like.
Then how do you add the coefficients?
You can't.
You can't because they're not like terms. Okay.
All right, so these are terms with different variables or terms with the same variable or variables raised to different power are unlike terms. Okay, so if we have different variables or different exponents, then, or different variables or the same variables with different exponents, they're unlike terms. Unlike terms cannot be combined by addition and subtraction because they're different things. It's like apples and oranges. 2 oranges plus 3 apples. What do you do with that?
I don't know.
You really can't. You can't say you have 5 vorangiples.
I like that word.
That's a good word.
That is a good word. We should make a dictionary.
Orangiple.
I
Yes.
did etymology last year. We made up
Okay, great. All right. Very happy for you. Okay. So the process of combining like terms, guys, the process of combining like terms is that we're going to combine their coefficients by addition, subtraction, based on the sign. We'll use our sign rules. You guys are familiar with this, so it should be pretty quick. Now, this direction here says combine like terms, but let's just identify which of these terms are like terms.
The first and the last.
3x to the fourth and
5x to the fourth.
are like terms, and then 5y to the fourth is not like either of those, right? So because they have the same variable and same exponents, those two things are like terms. So you might be, and be careful, be very careful, a question on a test could say identify the like terms in this expression.
Okay.
It's not telling you to do what? Combine them. It's just telling you to identify the like terms, and that could be a possible test question. 3x to the fourth and 5x to the fourth are like terms. 5y to the fourth and the other two are unlike terms because they have different variables, right? The same exponents, but different variables. So to be like, they have to have the same variables and the same exponents, right? Okay, now, the coefficient, notice this last thing, this is important. The coefficient is never used to establish whether terms are like or unlike. We don't care if the coefficients are the same. Okay? If I have 3 horses and 2 more horses, the horses are like regardless of how many there are. Right? 3 pigs and 2 pigs is 5 pigs. Okay? So just kind of keep that in the forefront of your mind. All right, so now we're actually simplifying expressions. Combining like terms. Elijah.
Love that.
Why?
Because you just add their like terms and you just add the coefficients together.
Why didn't you change exponents there?
Because they stay the same whenever you add them together.
Why?
Because they don't change when you're not multiplying as well.
Because they what?
They don't change until you multiply them.
Or
Divide.
or
Subtract.
no.
Subtract.
Yeah, raised to a power, right? If the only operations, y'all listen, the only operations that can change exponents are multiplication, division, and other exponents. So we have an exponent raised to an exponent, that changes the exponent. But when you're adding things, the things don't change. 5 pigs plus 7 pigs is 12 pigs, not pigs or pig squareds. You know, it's just 12x.
Wait,
in this case.
when you say a power raised to another power, are you
Yeah,
talking
like-
about like the base? And
I'm
then,
talking
like,
about something like 5x cubed raised to the third power.
Okay, I thought
Oh,
it was
okay.
when I was
That would change exponents,
I
right?
mean, it would be 9.
Because that's really just multiplication, right? That's
That's
5x
fine.
to the third times 5x to the third times 5x to the third. So that's right. And division can change exponents. All right?
27.
Simplify this one for me, Isabella. Shh.
Oh.
Isabella.
Negative 4y plus 3y, which is
Negative 4y plus 3y.
negative 1y plus 5y, which is 4y.
4y. But we could also take these two positive ones and combine them, right? Get 8y. 8y minus 4y is also 4y. So however you slice it, you get 4y. Keep in mind that we do not change the exponents because addition does not change exponents. When you add like terms, the exponents do not change. Only the coefficient changes. All right? Now this is beyond the lesson. This lesson doesn't do problems like this, but we are. And this is the kind of problems that you'll be quizzed on Wednesday. So if we're simplifying this, one of the ways that we define simplify in an earlier lesson is, at this point, it means get rid of parentheses, combine like terms, take square roots. That's the stuff that we've done up to this point. So simplifying here, we're going to get rid of parentheses and combine the like terms. So Jack, how am I going to get rid of parentheses here? Yes, you do. Speak out. Huh?
Combine the like terms.
Well, we do that later. We got to get rid of parentheses first. I don't have it. I've got 2 terms at this point, right? That's a term and that's a term, and I can't combine those. You got to use the distributive property. Good. So what would I get when I distribute to the first parentheses?
6x plus 24.
Okay. And now, Jack, what am I distributing to the next parentheses?
Negative 3.
Good. So what am I going to get when I distribute to negative 3?
Negative 6x minus 21.
Minus or
Positive.
why is it positive?
Because a negative times a negative
Thank you. All right, so that's the tricky part of this problem, right? And I promise I'm going to give you lots of negatives to distribute because you've got to get used to that. That's a common mistake that we've got to conquer. All right, so then we can combine like terms. These two are like terms. These two are like terms, right?
Fancy.
Fancy schmancy. 6x minus 6x is 0x.
Oh.
No more x, right?
So it's
Five.
just 45.
So 45 is the correct answer. Do not write 0x.
I was about to ask
And
you
certainly
first.
do not write x if there's 0x, right?
Then that means they're
That
1x.
means 1x.
Right, because
Sorry,
x
1x,
is one.
but
You guys have been taught well. Kudos. All right.
Good job, Miss Sorrels.
All right. Yes, shout out to Miss Sorrels. Chuck, simplifying this, we need to identify the like terms. So, Charlie, which one of these are like terms?
3k squared and 2k squared, 4k squared,
Ah.
All right, these two are like. And,
and 4x squared.
all right, what else? Those three. Any other like terms?
The last two were.
These two are
Like term.
also like terms, right?
Here's the one.
Okay, so, and I encourage you, if you've got an expression that's got a bunch of little things, do something like this. You know, underline one of them once and the other like terms twice. And if you had a third pair of like terms under it, use 3 little lines. So you make sure that you get everything, right? Make sure that everything is involved. So we're going to combine these 3 like terms, and we're going to get what? 5k squared. And we're going to combine these two and get
3K.
plus 3kx to the 4th. And again, I'm not changing exponents because only multiplication and division can change an exponent, right? Okay, everybody good with that? All right, try this one. Now I'm doing some multiplying here, which is going to change exponents. And then we're going to identify and combine like terms. Thank you. Okay? How are we doing?
Good.
Good.
Pretty good. How are you?
Good, good.
Had the gum since right after lunch, and it's starting to lose its taste.
That's what I've had to do.
I got -6 since I lost its taste. I was juicy fruit.
All right. Talk to me, Madison.
Oh, you made me lose a train of thought, so I was just about to be done. Wait 1 second. Negative.
No, I don't want the answer. Tell me. I want you to walk me through it.
When you distribute the first one, you get 2x squared plus 8x.
Okay.
Then
Right.
for the second one, you would get negative 3x squared because,
Okay.
and then you would add 18x.
Plus 18x because negative times negative is positive. And
you
then
add x.
we got this straggler plus x hanging around, right? There's going to be, you got to be careful not to forget that term that's hanging out there. Now we have to identify like terms, right? 2x squared and negative 3x squared. And then the other 3 are all like, right? X to the first. So what do we get when we simplify that? Negative 1x squared. You can write the 1 or not, I don't care.
Plus 27.
Plus 27x.
Yay.
Only 5 examples today, or is there more?
Man, man's ready to be done, isn't he?
I want to start on my homework.
Okay.
Oh.
Elijah.
Now, let's don't actually do this one, but there's something that's a little bit tricky here that they're trying to get us to see.
Y, X, and
The
X,
third
Y.
term and the first term are different.
How are they different?
Because that
Y is
one has
first.
Y is, oh wait.
No,
The X
it's
is
not.
first and the Y is first.
All right, so they're different, but y'all listen. Shh, 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 shh. They're different. That's not really a math term, is it? I mean, yeah, they're
Not
different.
like-
They're unlike.
They're unlike, or are they like?
They're like
No,
terms,
they're
but
like-
their variables
they're
are
like
of
light
switch.
and light.
Look like
It's
they're
too
supposed
much
to be
more
like, but
brain.
they are. They are.
What is the definition of like?
The same.
Same variables and
Same
same exponents. Does it say anything about the same order?
No.
No. Doesn't say anything about the order. It doesn't say anything about the coefficient. And order doesn't matter because multiplication is
Add repeated addition.
commutative, right? So we can commute our multiplication and we still have equivalent
So
statements.
then what order do you put them in? Alphabetical?
We'll talk about order in just a second. So these two are like, right?
Uh-huh.
Because they both have x squared and y cubed.
But then the other two are right.
These two are also like because they both have x to the first and y to the first. So let's combine these two. -6, right? X squared y cubed minus 4xy. Now this is if we're getting real technical, this would be the way that most proper way to arrange the terms because the degree of this term is higher, the exponents are larger. If you add the two exponents together, you get a degree of 5. This one is only a second degree term, so it would come later. Okay, and the variables are arranged alphabetically. Now there's some rules there that aren't hard fast rules, but that's kind of where we go with that. All right, last example. Olympic competition offers 3 equestrian disciplines that really no one cares about.
Huh? I used to do that stuff
Used to? Why did you quit?
because I had so much stuff to do.
Because no one really cares about it. Okay. Dressage,
Dressage is
I used to jump.
show jumping, and endurance. Dressage is really makes sure
It's like,
you dress your horse correctly
Yeah.
and
That's dumb.
put the right clothes on it.
Yeah, that's
Is it,
dumb.
which one, what's the one where you like, its legs go different ways, Brooklyn?
What? That's
The one where it's like super fancy and it goes like.
That's breakdancing, horse breakdancing.
Oh, no.
Equestrian. Can y'all see an equestrian like horses
One
doing
goes-
some?
I think it's
Okay.
dressage.
All right.
It's like insane.
Back to
She meant the running.
the problem. The diagram represents the measurement of a regulation dressage arena. Find the perimeter of the arena as a simplified variable expression. Then evaluate the expression for x equals 19.5. So we're going to use what formula here? Perimeter equals twice
Twice times
the length plus
Twice
twice
times
the width. Okay? Then you would
Substitute.
distribute. Distribute, it says to write it as a simplified expression. That means we get rid of parentheses and combine like terms. And then the last step, you would substitute 19.5 into your simplified perimeter expression to evaluate it. Okay? Any questions?
No, you actually already did this problem.
No. Your homework is page 100. We made it to the first 100 pages of the textbook. And A through G, 1 through 19, and a worksheet that I'm about to pass out. And we will have a quiz on Wednesday on these skills. Okay?
Okay.
All right. Thank you. Remember to like, comment, and subscribe.